Good evening, this is Professor Khan, and this week we will talk about chapter 4 from the book, and it covers electric meters. We will touch base on the past electric meters, which was analog, and we'll talk about the current ones, which is the digital, and what are the differences, and how do we pick a good multimeter for our job. Okay, let's start. So the objectives will describe the use of volt-ohm meters. Again, in the past, they used to have a meter for resistance, another meter for voltage, another one for amperage. We used to have a lot of tools, a big bundle of tools. As technology has advanced and we have different, we have smaller transistor like equipment, we can manage to do measurement with smaller multimeters without the need for large and multi equipment. So we'll talk about what we have now, which is basically the multimeter and the functions, and I will describe to you the three types that we need to use in the field. They used to have three types, but there were different kind of meters. They used to have voltmeter, ohm meter, and ammeter. We still have three types, but they kind of evolved a lot. And I will touch base a little bit on analog meters and how did they function in the past, because that is a little bit irrelevant to what we do these days. Okay, operations, advantages and disadvantages. We'll also talk. I don't think the resistance of the multimeter matters anymore, but the term of continuity is very important. I need you to remember this. Okay, these are the key terms that we will cover. Hopefully, they will sink in. I'll give you a second to look at them. So we have an ammeter, which measures amperage. Analog meter, something of the past, has a needle that goes back and forth. There's the window here, and we have a needle that goes back and forth. Clampon meter, that's something we used in the first few weeks. Continuity is a very important term. It basically checks to see if the circuit is complete. So if you have a circuit with a cut in it, if you try to measure continuity from here to here, it will tell you that there is disconnection at some part. Digital meters, magnetic field, measurable resistance. There are some resistance that you cannot measure, they're very small, but they could be still another path. Ohm meter measures resistance. Open circuit, short circuit. So this is an open circuit. What is a short circuit then? A short circuit is when we have another path that is complete but is not the right path. And we'll talk about volt-ohm multimeters. Okay, so again, three types of multimeters in the field. The three things you need to measure. We said in every circuit there are three components we need to always focus on, which are volts, which is electrical potential, amps, which is the flow, and resistance, which is the loads. So loads, flow, and source of power. Again, two major meters. The first one is the multimeter, which measures everything except for amperage, and I'll explain to you why. Again, same repetition, three basic types, and you need to know the right proper meter for that measurement. And again, as I said in the past, they used to have a dedicated equipment for each one of those, so it's a little bit different. Now we have a multimeter, but we still have to put it in the right setting for it to function and give us the measurement that we need. Okay, so what the multimeter does, if you want to wrap your mind around it, is basically Ohm's law in practice. So if you want to measure voltage, resistance, and amperage, if you want to measure voltage, you're going to run small little amperage through a resistance inside the multimeter, and the multimeter will does the math for you and give you the volts, and vice versa for both other components. So this is kind of explaining to you how do we measure the magnetic field around a wire. So whenever we have current running through the wire, there's a field that's going around it, and that field is measurable depending on how strong it is. And this is the basis the basis of using the voltmeter pin, which lights up whenever it detects voltage, and also the Clampon meter that measures the field around the wire. I know it seems kind of weird to put a Clampon around the wire where it's not touching anything, but it's giving you measurement. It's measuring the magnetic field. So I hope you don't put the Clampon meter on the wire, because that's actually a silly mistake. Okay, so in the past we used to use a needle to measure the, not a needle, use something like a magnetic analog needle to point out towards the, whether further or closer to the wire, to show us the amount of voltage or amperage going through the wire. So that's kind of the basis of how does the analog meter work, but we don't use that anymore. Now we use this field to measure amperage, and also to detect voltage. And you can also think that if you detect small voltage, it's really hard to measure that little magnetic field around it. Ammeters. So again, till this day, the main way to measure amperage is through using this magnetic field. I mean, you can measure small little amperage by putting a multimeter, after you set it on amperage, in series with the circuit. So this is something also you need to remember, that ammeters are connected in series with circuit, and voltmeters are connected in parallel with the circuit. So this is in series with the circuit. So again, the clip-on meter has to go around one wire, and we saw in the lab that if you put it around two wires, probably it will cancel each other and give you the wrong measurement. And the equipment has to be on, and one wire, and in series. Okay. The voltmeter is connected in parallel with the circuit, so the circuit has to be on, and if you see here, we are connecting this in parallel, on, and it will measure the potential between those two terminals. And they say there is resistance added to prevent direct short and allow electron to flow in the meter. So that's again in the past. There is a resistance here that you have to set it at the right voltage, but now most voltmeters are rated up to 600 volts, which is enough to measure. If you're going more than 600 volts, probably you need a bigger resistance, otherwise the amount of voltage is going to burn out the resistance. So when we try to measure 10,000 volts, like for the electrodes, you probably cannot do that with a multimeter. So pay attention to the range. Alright. Ohmmeter, then measure. They're very important because you want to know whether something is continuous or not, or there's resistance. So if we want to test a fuse, you measure for the resistance. And if you want to measure if you want to see if the circuit is continuous or not, you probably will measure for the resistance. If you get no resistance, that means that the circuit is incomplete. So you can check for open circuit, you can check for open components, you can check for shorts, you can actually check for actual resistance. So those functions are very important to know if something is functioning or not, because if you have a light bulb and you put the leads, if you set up your multimeter on resistance and you put the leads in the light bulb and you see nothing, that means the light bulb is gone. So it's a good way to check for continuity in the circuit and check if the load is running or not. And continuity is another function that based on resistance, but it's very sometimes it could be very small resistance where you see maybe nothing because the amperage you're putting is not being received well in the multimeter, but it will give you this continuity. So maybe the resistance may be 0.0001 ohm, but if you have continuity, you probably can hear the beep. There is continuity, but the resistance is not, it's very small, that's not measurable. So that's the difference. And continuity usually give you a sound or in some meters give you a 0 or 1. Here's an example of multimeter, 3 types, and this is a measurable resistance, so you see something. So this shows you that there is no resistance at all, and this shows you infinity. And if you notice, this is a digital meter, this is in the past. So infinity, if you have open resistance, no reading at all. Here we have a short, there is no resistance, so the load is connecting, but there is nothing to be measured. It's so small, and again, that's in digital. I mean, that's in analog, not in digital. Why do we get a 0 here? If you think about it, resistance equals voltage over amperage, right? I'm sending, probably this meters have a battery in it. It's sending amps going through, and if it's coming back with nothing, that means it's dividing whatever voltage here over 0. So when you divide, let's say 12, whenever you divide anything by 0, you get infinity. So that's the other side. You see, it gives you infinity. But that's again in analog, and we don't use that anymore. Usually now you'll get a 0 if you have a short, and if you do continuity, even if you get 0, you will not get any beeping sound if you have an open circuit. I hope this illustration kind of makes it clear a little bit. Okay. This is to measure the resistance. One thing about the resistance, it has to be in parallel. Also off. Do not measure resistance of things when they're on. That's very important. Otherwise you might zap yourself. And again, the resistance of a lot of loads changes as it heats up. Whenever something is on and it gets hotter, the resistance will increase. So two things happen to a wire whenever you run current through it. I keep saying that repeatedly. It will generate a magnetic field and it will build up some heat. This is what I explained before. There's a battery inside the multimeter, inside the ohm meter, and this is how we send some kind of amperage, and we measure how much of that amperage was consumed by the load to measure the resistance. And again, this is the analog. So these are the current types of multimeters. The voltmeter pen, you need to have those 3 with you all the time. So the pen, the multimeter, which has all the functions, I'll show a picture, and the clamp-on meter. You need the clamp-on meter, you need the pen, and also you need the multimeter. There are some clamp-on meter that have it all. It has the detection part, and it has a multimeter. So we'll show a few of these. So this is the voltmeter pen. It detects voltage all the way from 24 to 240. It turns color and also beeps to tell you that there is voltage or not. And it's very important to see if you're receiving voltage at that point. It might not be accurate, and it might be susceptible to noise. By noise I mean the other voltage around it. I mean, look at these wires. It's a big bundle of wires here. So if you touch it, you have to be very specific. Touch that terminal by itself, otherwise it might be detecting things from the other wires in here. So that's something you want to have around you to see if there is voltage or there is not, or there is no voltage. And again, it goes from 2 to 240. And second thing is the clamp-on meter. So this clamp-on meter by Fluke is the 902 model, and it can measure amperage because it has the clamp-on ability here. If you look here, you have to set it on amperage. It has amperage AC. So this squiggly line you see over here is AC. This part is for the capacitors, which is very nice to have because you need to do that for ACs and for some motors. And here you see the temperature. How does it measure temperature? There are some leads that you connect in here, and they have a sensor, which is a thermocouple that you can put in the equipment to measure temperature. This part here is for micro amperage, which is very, very small amperage that you cannot measure by the clamp-on. And again, you have to use the leads to do that, the leads, and to connect those leads in series, as we said before. This part here is the, let me change the color. Here is the resistance. So this is the resistance. It should give you measurement here, and if you use that function which looks like a wave, it will just beep to tell you whether we have resistance or not. And at the bottom there's the voltage. And again, I've seen this mistake before where people just mix and match the clamp on and they wish for voltage, but it's not going to happen. The clamp is only for the amperage. So amperage is the clamp. Volts, you're going to use the leads here. There's as you see, something that is common, which is neutral, and the power. And that's all to it. And there's actually, some of them have apps that you can connect and get the reading so you can record. And usually in the display you'll see whether it's AC or DC. So that is a very valuable tool, and probably that's all you need for going on the job. But you also will need the voltmeter pin as well. Again, this is another multimeter by Fluke. I think it's a 116F, and look at the function it has here: voltage, AC and DC. So the line is DC, which you see in here, right? And the squiggly line, that's AC. And if you look at the HZ here, that's the frequency. So sometimes when we work with control, we would like to know what is the frequency of that voltage, because it's very important for the control to function within 60 Hertz, sometimes from 55 to 60 Hertz. Resistance is measured in here. Continuity, if you want to go with the leads and measure continuity, and I would love for you to practice that in the lab a little bit. This for the capacitors, which again, it's measured in farads. Temperature again with leads, and microamps as well, and has to be connected in series. So I hope this kind of covers up what we need to know about multimeters, and it's one of those things that you have to practice a little bit and try to play with it. The main thing you have to pay attention to is the range, and this one is O2 ranging, which means you don't have to change the range. If you look at some of the older equipment, probably they will give you voltage and range of voltage, for example from 0 to 100, 100 to 200, 200 to 40, and so on. This one will take the lead all the way, will take the range all the way from 0 to 600, and actually that plays a major role in the price of the multimeter. So again, check the range when you use the meter, check the information, what are the limitations. The prices of the multimeter vary a lot based on the range, the calibration, the quality, and how frequently you need to have it calibrated and maintained. Calibration is very important. It's really a good idea to have a backup meter to make sure that the first one is giving you the accurate reading, especially as they get old. Sometimes they need to be maintained and calibrated. So yeah, it's good to have always a backup, and always check the battery in the meter. Have some backup batteries for those multimeters. Some of them have an indication that tells you that the battery is low and it's about to go, and some of them don't, so it will be just not a good idea to go without a backup battery and suddenly it dies on you. Okay, that's all I have for you for this lecture, and I'll post this video and some homework